Okay, this is where we left off in the previous video. So let's call this point over here G. I basically want to find AG, which is the perpendicular distance, right? That will give me the shortest distance from A to the path BC. Okay, so how do I do that? Now, because I already found the area of ABC and I know the length of BC, I can use both the area and the base over here to find the perpendicular height. I think as long as you have found the area, always use that information to find the perpendicular height. Okay, so I'm going to start answering over here. First of all, I will start by saying let G be a point on BC such that AG is perpendicular to BC. This will let me know that, okay, that's the perpendicular distance and that is the shortest distance. Now the area that we found just now is equal to 1757.2, right? I'm going to equate this 1757.2 to half times base times height. Just now the BC that we found, right? BC will be the base and that is 77.597. 77.597 times the height, which is AG. So I formed my equation, I just have to solve for AG. So AG is equal to 1757.2 times 2 divided by 77.597. 2 times 2 divided by 77.597. Answer will be 45.290 to 5SF. So the 3SF value is 45.3 meters. This is the shortest distance. Okay? So that's for part D. 45.3 is the answer. Now part E says, calculate the greatest angle of elevation of the top of the tree when viewed from any point on the path. So the path is BC and a man is walking along BC, but when will he have the greatest angle of elevation? As I covered in my previous videos, I mentioned that the greatest angle of elevation is from the shortest distance. So basically the man must stand at G, exactly at point G, and look at the top of the tree. That will give him the greatest angle of elevation. Now when he does that, realize that this will be his line of sight. DAG is the triangle we're looking at. So let me just draw the side view. DAG is here. DAG will be a right angle triangle. AG, as you found just now, was 45.290 meters to 5SF. DA, you already found out the height of the tree, right? Over here, 20.694 meters. This is exactly why we need to write down all the 5SF values, because we are using all the 5SF values in the parts. Okay, so the greatest angle of elevation, right, will be here, which is angle DGA. So form your equation. Tangent of angle DGA is going to be equal to opposite over adjacent. Therefore, angle DGA is equal to tangent inverse of this whole thing, 20.694 over 45.290. 20.694 divided by 45.290. Tangent inverse of that will give me 24.6. Okay, it's 24.556. So to 1 dp it will just be 24.6. And that's my greatest angle of elevation. Okay, so it's so typical. In fact, the question has helped you in part D because they asked you to find the shortest distance first, then after that followed by the greatest angle of elevation. So it all flows very nicely as long as you can visualize. Okay, so with that we end this entire chapter, chapter 12, but I'm going to give you some questions from the textbook so that you can practice on Foolscap. Now, if you want a quick summary, it's on the last page of your notes. So what are bearings, what is angle of elevation depression, and how to solve problems which involve 3D. Okay, so for your homework, can you please do exercise 7C from your textbook, Sec 3 textbook? Okay, questions 7, 11, and 13. 3 questions for you to do on Foolscap and upload to Google Classroom. Okay, please try them and be as sincere as you can. Put in the effort to really try and understand what's happening, because your class test is coming up really soon. Okay, it's like in 2 weeks time, and the chapters that are going to be tested are huge chapters like graphs and algebra and trigo. So please be consistent and just make sure you understand everything until this point. Okay, if you don't, next week make it a point to find me for consultation on Zoom or text me your questions, and I'll be more than willing to help you. But make sure you have watched all the videos and tried all the questions from the textbook. Okay, I hope to see you in class next week, and hopefully we will have good sessions face to face. Until then, please take care and stay safe. I'll see you next week in class. Bye.